Hello everybody, this is Alex Markowitz, Theo Miller, and Sam Cook, and we're doing the shopping carts problem. To begin, let's start with our given information. We know that one cart is 58 inches long, and that a line of 12 carts is 256 inches long, or 21 feet 4 inches. Now, our first problem is to sketch what a line of 12 carts would look like. 12 carts looks like this. Next, we want to find out how much is added with each shopping cart. The first cart adds the full 58 inches, but subsequent carts add a smaller number. Let's start by subtracting the length of the first cart from the total, or 256 minus 58, which equals 198. This represents the length of the remaining 11 carts, so we divide 198 by 11, which equals 18 inches added by each cart. Now we want to find the particular equation for the situation. If f of n is the length of the carts and n is the number of the carts, find the equation for f of n in terms of n. This situation looks a lot like an arithmetic sequence because you add a given length each time another cart is added. Remember, the explicit formula for an arithmetic series is t sub n equals t sub 1 plus d times n minus 1. Now, plug in the known values. T sub 1 equals 58 and d equals 18. T sub n equals 58 plus 18 times n minus 1, or f sub n equals 18n plus 40. What is the domain of our equation? First, consider that since we are in the real world, it is impossible to have a negative shopping cart. Then we can realize that we can't have a fraction of a shopping cart. And of course, we also can't have 0 shopping carts or we would be wasting our time. Therefore, the domain must be all natural numbers. How long is a chain of carts 24 carts long? Remember, our equation is f of n equals 18n plus 40. Begin by plugging 24 into our equation as n. F of n equals 18 times 24 plus 40, or f of n equals 472 inches, or 39 feet 4 inches. What kind of function is the function we just used? Well, we know that our equation is arithmetic sequence, but what kind of function is it? We can see that the number of carts increases, the length increases by a fixed amount as well. This is the characteristic of a linear function. Now, our store has exactly 24 feet of space to put a single line of shopping carts in. How many carts can we fit into the space without exceeding our allotted space? Plug in 24 feet, 288 inches into our equation and solve for n. 288 equals 18n plus 40. 248 equals 18n. n equals 13.7, repeating. Now we run into another problem. Our domain is all natural numbers, so it can't actually be 13.7. If we round it up to 14, the carts wouldn't be able to fit in space, so we have to round down to 13 carts. Congratulations!